So yeah, I just went over the solutions and for the strategies, I'll be updating the doc later. But now I'll just go through the questions. Yeah. So for part one, um, it's a pentagon, and it has side lengths of 2 centimeters for each side. Pentagons have 5 sides, so 5 times 2 is 10, which is E. Okay. Uh, yeah, I'm just gonna so 2 times 5. Yeah. Next, the face of cubes is that 3 of the faces are shown. What is the total number of dots on the other 3 faces? Well, the other 3 faces is 2 plus 4 plus 6, which is 12, which is D. The equation that represents a number increased by 5 equals 15 is, uh, when I saw increased, I immediately thought, okay, addition. So I look at the answers and my eyes drew immediately to D because I saw a plus sign. So I just did D without actually looking close enough. But it should be C. Sorry. Yeah, C, because it's number increased by 5, not increased by 15. So yeah. Um, the line graph shows the number of bobbleheads sold at a store each year. The year that increased the most is from like this section, which is actually, let me use a red pen just so that we know what's answers and what's the work I did. So it's this section, and that's from 2019 to 2020, which is D. Yeah, 5. Um, s Starting from 72, uh, Arnya, Ar, Aryana counts down by 11 and what is the last number that's greater than 0? So, um, the way I did it was I know 44 is divisible by 11 because 11 times 4 is 44. So, if you started from 44, you'll get to 0, but we're at 50. So, let me just draw this out. 44, you will get to 0. And 50 is it's not at 55, it's less. So 50, you count down the exact same number as 44. And 50 is 6 more than 44. So if you count down the same amount, you end up at 6. Yeah, so 4. And that's how I got 6, and that's C. Yeah, 6. Um, in the diagram is 90, value of x, so this is simply 2x plus 44 will equal to ABC, which is 90, which means 46 equals to the 2x, which means x equals to 23, which is B. Okay, right? Right, yeah, okay. 7, what is which of the following values is closest to 0? So this is like absolute value. So for A, that's 1 away, because the rule for absolute value is like di distance is this. So it's a number minus the other number, but then you take the absolute value. So if it's negative, it becomes positive. If it's positive, it stays positive. So like negative 1 minus 0 is negative 1, but then if you do the positive, it's 1, so the distance is 1. B, this value is greater than 1, because 5 is greater than 4. C, it is 1. D, it's between 0 and 1, so the distance is less. And E is also between 0 and 1. Now, um, for D, what? This is equivalent to if you just uh, times 2 on both sides, both like top and bottom, it's 8 out of 10, which is equal to negative 0.8. So we know that negative 0.8 is like 0.8 away from 0, but then E is 0.9, which is greater, so we want the minimum, so it's E. Oh, sorry, D. Yeah, D. Next, 8. Uh, yeah, at first this is the question where there's a jar containing 267 quarters, and then the total value is $100. So I was about to like calculate uh, what is the value of the quarters in the jar, and then minus by 100, and then divide it by 4 to get the quarters. But I realized that um, I think the smarter way of doing, because if you want to calculate the value in the jar, you need to do like 267 times 0.25, and then it's kind of off because 7 is not like this is divided by 4 basically, and 267 is not divisible by 4. But if you first calculate the number of quarters in 100 and then minus, it's way faster. That's what I realized. So $100, and each dollar needs 4 quarters, so times 4 equals 400 quarters. And then when you do minusing, it's easier because there's no fractions. So you just do 267 minus uh that's 3, and then that becomes 9, 9 3, and then also needs, no, you don't need a carryover to wait. 230, wait, 400. Mm. Oh, right, sorry. It becomes a 9 after you do that. So that's 133, which is D. 9. Uh, right. This uh there's a package with 8 greeting cards and 10 envelopes. Kira has 7 cards but no envelopes. How many of these packages she needs to buy? So you don't actually care how many greeting cards or envelopes you have per package. You just care about how what's the change in the total number of total number of total number of missing cards. So because the 8 greeting cards take up 8 envelopes, so those 8 envelopes are like rendered useless. So each package will give you uh, 2 free envelopes, because you only care about the free envelopes. The taken envelopes are useless, which means uh and Kira? Oh yeah, Kira with 2 R's, what? Has 7 cards. So each card goes to 2 envelopes. So if you get 3 of the packages, right? 3 packages times 2 free envelopes is you get 6 free envelopes. But Kira has 7 cards, so 3 is not enough. You need one more, which is 4. Because if you get 4 envelopes, and then each one has 2 free envelopes, that's 8 free envelopes. Kira has 7 cards, so that's just large enough. So 9 would be B. Yeah. Let me just write over here. Anyways, uh, and then 10 is yeah, which of the statements is true? So you see how these points are like this? What that means, uh, A and B are larger than C and D, which are larger than E and F. Like the x value of the x value and y value of this point will be larger than the x value of y value of the other points respectively. So you just look through the options and see which one is true. E larger for A, E larger than C, no, it's this point and that point. B smaller than D, no, B is the at the largest point. F larger than B, no, it's smaller. A less than E, A is the largest one, but A larger than C, A is the largest one, and then C is the second, so A larger than C, which is E. Yeah. 11. Just start over here. 26 letters of the English alphabet. This repeating loops, blah blah blah. What's 258th letter of this sequence? Well, the only way to do this is to list out A, B, C, D, E, F, G 10 times and be tired. No, 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 of course not. Okay, so 260, 26 letters, right? So we'll just do this smartly because we don't care what's in the middle. We only care what's at the 258th spot. So um, A is in the first spot, okay, and then Z is at exactly the 26th spot, right? Because A is the first letter, Z is the last. So first letter is 1, which means first corresponds to exactly uh, the placement of the letter. So Z is the last one. There's 26 letter is exactly 26. Okay, now we got that straight. Uh, and each time you add 26, like each loop, there will be another 26 letters. So the next Z will be at 2 times 26. Exactly. And then at A, it will be 1 plus 26. Or here you can say 26 plus 26. Anyways. Okay. Now at the 258th, so I know positions that are divisible by 26 will be Z. Exactly, because this is 2 times 26. The next one will be 3 times 26. So if it's divisible by 26, it is Z exactly. So I know 260, what 260 is divisible by 26 because this is equal to 26 times 10. So at the 260th position, this is also exactly Z. So now you just count backwards. 259 will be Y and 258, which we care about, is X. And the reason I chose 260 is because it's suspiciously close to 258. So yeah. So X, which is C. Mm, X 12. Uh, this public holiday question was seen in the grade 7 exam. I'll just show again. Uh, what? So the idea was what could possibly prevent a third Wednesday of being in a month, and that's if it's out of the possible range of values. So we want to find what's the minimum it can be, what's the maximum it can be. So one of the extremes, if the first Wednesday is exactly the first day of the month, so that will be Wednesday here, and then the next week 7 days will have passed. So it's add 7 exactly. So that's 8. And then the next one is 15. So this is the minimum, right? Because the minimum is if the first day of the month starts on the Wednesday. Yeah. And the first day of the month is the minimum value of the first day, if that makes any sense. So the minimum is 15, and you see all the values are greater than 15, so that's not the uh, that's not the thing that's going to reduce your options. The next one is find the maximum. And the maximum is if the first day lies, the first day is over here, which means the Wednesday has to occur on the next week. This is a Thursday. The Thursday has to occur on, so the next week. So if this is 8, because 1 week later, then the first Wednesday will occur on the 7th. Okay, and then the next one is 14th. Ah, yeah, because add 7. And the next one is 21st. So this is a maximum that the third Wednesday could be. And then you'll see that B, option B, exceeds this maximum because option B is 22. So that's why B is the answer. Yeah, I wrote B. Okay. Um, next, 13. Uh, Circular spinner divided 3 sections. Uh, yeah, and then largest is 50, next is 1 3. So, um, actually, this diagram is kind of correct. This is the first section, right? Because largest section is 50%. So you could draw the 50% however you want, but the most obvious is just divide the circle in half. And it doesn't even need to be circular, really. But circular is good because it feels nice. The next the probability it stops in the next largest section is 1 in 3. 1 in 3 for probability, if you do 1 in 3, that's literally just 1/3. It's not ratio, it's just probability. So that's like 1/3. And this is 50%, like half, and then this is a third. So, oh yeah, and probability is if you think that like just throwing darts is it's location independent and it's gonna land somewhere on the circle, then the probability is uh it's what's the word? It's proportional, yeah. It's proportional to the area of the circle. Of the portion that you're looking at. So the last part is what's 1 minus the half section minus the third section? That's a sixth, right? Because if you want to do it slowly, it's half is also equal to 3/6, and then a third is equal to 2/6, because you divide 2 on both sides. So that's equal to 5/6, and then the remaining section will be 6 minus 1 over 6. 6 minus 5 over 6, which is equal to 1/6. Yeah, and that's C. 14. Um, a positive number divisible by 3 and 4, tens digit greater. Okay, so yeah, so if you have a positive number divisible by 3 and 4, obviously that means it's divisible by 12, right? So you just count. Um, so I know it's let's just list out the 12s because there's not that many. 12, 24, 36, 48. But notice how these ones, like since the ones digit hasn't overflown yet, overf overflown? No, overfilled. Sorry, sorry. Okay, since the ones digit hasn't overfilled yet, um, the ones digit will always be larger than the tens digit, and that's not what you want. So you need to go to the next one with it, which is 60. So you see how I started 60. And then you just keep counting up 60, 72, 84, 96, and then the next one will be greater than 100. So, oh, and if it's greater than 100, that's 3 digits. So you just, there's 4, so 14 is A. Sorry, yeah, sus. Never mind. Oh, okay, next 15 is this pool, and you want to see the shaded region. I kind of, there's a nice diagram over here. So, um, let's see. Yeah. So you just want to add up all this part. That equals to, uh, this is 4 times 1, because this square is 1 by 1. Next is 2 times this long square, and we know it's 20. This is 20, so 20, and then 2 times the short rectangle, which is here, and then this is 1 by 8. So 2 times 8. Yeah, and then when you add it all up, that's equal to the 4 and the 16 make 20, and then plus 40, that's 60, which is uh, 15 is B. Okay, next. 16. Uh, the results of asking 50 students if you have a Venn diagram was the students outside of this. So when I see Venn diagrams, there's a famous equation where it's like, let me make more space over here. Okay, here's 16. When you see a Venn diagram and like A, B, uh, there's a famous rule where total A or B, or this is the symbol for or, equals, like the number of A or B is equal to the number of A plus the number of B, but minus the overlap, A and B. And this is the symbol for and I see a lot of Among Us today, but ignore that. Anyways, yeah. And then my mind at that time automatically jumped to this equation, which, I mean, it's a shortcut, but always be careful. And the way I did it was not that good because I only discovered how wrong I was at the end. But uh, yeah. But the problem is in that example, this value and these values were completely separate. Like this value was not B. This value was only B. So B and is it not A? Like B and not A, not just B. So you don't need to care about overlaps or anything. It's just adding. All this to say, okay, so you got 50 students. So it's just the music only plus the overlap plus sports, but then it's total minus this stuff, which is 50 minus what is it? 15 plus 5 plus 20, 15 plus 5 plus 20, which is 50 minus 35, which is no, what? Right, give me a sec. Oh no, sorry. Oh god, it's uh 50 minus 40, yeah, equals 10. And then we're trying to find the percentage. So 10 to 50 is equal to times 2, sorry, it's 5, times 2 on the top and bottom, numerator and denominator. You get, and then the percentage is a fraction of 100, so it's 20%, which is C. Okay, next. 7. Did I mess this up? Oh, I did mess up. Oh, and also I explained it in the uh, when I was doing the questions video. Yeah, so I showed the full thing over here. So this was correct. So anyways, there's a bin F and bin G, and the amount in bin F is 2/3 of that in bin G. So this is correct. Next, if there are a total of 150 golf balls, how many fewer golf balls are in bin F than bin G? For this one, you have to like do it slow. Oh, I mean, I need to do it slowly. So here is G plus F equals 150. And we want to find the difference between G and F. So the like clear way to do it is find the difference between G and F, or find what's G, what's F, and then find the difference. So yeah, you just plug in F as 2/3 of G over here, uh, and then you add the G's together. It's 5/3 because I'll just do it slowly. This is also equal to 3/3 G plus 2/3 G, because 3/3 is 1, right? And then 3 plus 2 is 5/3 G. And then now you simplify, multiply by, actually divide by 5 first, because that's easy. 150 divided by 5 is 30, and then times the 3, that's 90. So G equals 3 times 30, which is 90. And then F is equals to 2/3 of 90 G, and that's equal to 60, so the difference is 30. Yeah, so it's C. Next, yeah, it's another mod-ish question. So figure 1 is formed like that, figure 2 has 5 more squares. What figure has 2022 squares? Okay, so Um, let's see. Yeah, so I think I did it fine over here. I'll just use the same equation. So in the first figure, there are 7 squares. The next one will be uh the next one will be 5 more squares, so 12, and then 5 more 17, or and so on, right? But um so first I want to make an equation to decide how many squares there will be at the end. So uh the equation, if it's 5 more each time, so the 5 is related to the figure number. So I do the number times 5. And to match up with the first figure, okay, so figure 1 is 1. 1 times 5 is 5. And then how many more do I need? 2 more, right? Because 5 plus 2 is 7. So this is my equation. Now, uh, I know that 2020 is divisible by 5, which means that at 2022, you can just do it slowly. So number times 5 plus 2 equals to 2022, right? But so number times 5 equals to 2020, and then I do this division. Uh, it's quite simple because 2000 divided by 5 is 400, right? Because 4 times 5 is 20, and then add 2 more zeros is 400. 20 divided by 5, I just said it, is 4, so it's plus 4, which equals to 404, which is equal to C. Mhm. The next question is the rate question, or like speed questions and those things. To solve these questions, you just need to know total distance over total time, because speed is av average speed or velocity, I don't know, is total di distance over total time. Okay, so now you have to be careful not including break. So uh we want kilometers and hours. Okay, so let's just do it. Simple. Uh uh right. Total distance is 300 kilometers. Total time is 7 a.m. to 11 a.m. That's 4 hours. 4. But you minus 40 minutes. 40 minutes, there's 60 minutes in an hour. So we want to find the fraction that 40 minutes is out of an hour. So it's 40 min over 60 min. This is 1 hour, which is equivalently equal to uh 2/3 of 2/3. Wait, give me a sec. Oh yeah, sorry. 40 minutes over 60 minutes per hour. The minutes cancel out, so you get 2/3 of an hour. So 40 minutes equal 2/3 of an hour. This is how, so yeah, this is how you convert. So let's see. Yeah, because minutes divided by the minutes per hour you get back the hours, right? Okay, anyways, minus 2/3, which I'll just over here. If you do the math, you get 300 over 3 1/3, which is equal to 300 over 10 over 3, because 3 third, 3 when you over thirds is 9. Like in 3 there are 9/3, because there are 3/3 per one. Anyways, and then you add the 1/3, you get 10, and then like this is this thing. So you get 900, uh, which equals to 900 over 10, which is equal to 90, right? How can I explain that better? Oh, okay, I'll just do it slowly over here. This is equal to 9 over 3, like this bottom, plus 1 over 3, which equals to 10 over 3. Okay, there we go. 9 divided by 3 is 3, right? And then 1 divided by 3 is that remaining third. You add it together, you get 10/3. Okay. Ah, okay. Now we get uh, this question, which is geometry question. So blah 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 equilateral, four sides, midpoint, midpoint. Yeah, okay. So it's an equilateral triangle, so I just put in the um, orientation that suits me the best. So the question is finding this length, right? Uh, let's see. So this is A. This uh, this is C and this is B, right? And this is D. Right, okay, okay, right, yeah, okay. So, uh, when you do A to D, right, it's going to be perpendicular to C to B, so we know this is a 90 degrees. That's a property of, I guess, equilateral triangles, or more generally isosceles triangles, because if this is equal, then it's symmetric, so that angle will be 90. Okay, so um, and then and then uh, E is this midpoint, so this and this are equal. So you know what? Let me just make a bigger triangle here. Yeah. A C D B A C D B mm, E. So I know this, and this are equal, and then this are equal, and this are equal, right? Okay. So we want to find this. Okay. And the square root of that. Okay, now we're good. So let's start drawing. This is 4, that's 4, because it's an equilateral triangle. This is 2, and this is 2, because that's the midpoint. And let's find AD. AD using, and this is 90, using Pythagorean theorem, it's AD squared plus 2 squared equals 4 squared, because you're doing for ACD, right? So that's equal to AD equals to the square root positive of 16 minus 4, which is 12, which also equals to 2 root 3, because um, this is equal to 2 squared times 3. I'll just do it slowly. 2 squared times 3 times square root 3. And then 2 squared square root is just 2 root 3. Okay, so AD equals 2 root 3, which means, since we know DE is half of AD, DE equals root 3. Okay, so let's just fill that in, root 3. And now what's EC? EC, you use the Pythagorean theorem again. EC squared equals, actually we only cared about EC squared, so it's 2 squared plus root 3 squared, which equals to 4 plus 3, which equals to 7. Yep. And A? Yeah, A. Okay, on to the actually hard question. And not hard, it's just C questions. Um, C, like, okay, so 21. Positive factors. There are two perfect squares less than 100 that have 5 positive factors. So, well, you know 100 is 10 times 10, so there's actually not that many perfect squares you need to care. So let's look at the types of perfect squares there are. So if you have 1, right, there's only one factor, so useless. If you get 2 squared, you get 4, so you get 1, 2, 4, also not good. If you get, and then if you get 3 squared, you know it's going to behave the same way as 2 because 2 is like a prime factor squared. So again, you have the types of factors is 1, the squared, and the prime factor itself. There's only one. Now, 4 is different because 4 itself is it's it's not a prime factor. It's 2 times 2. So what you have, 1, 2, and then the so 1, the root of the of 4, which is 2, and then 4 itself, and then uh 4 times 2, which is 8, and then 16. This is perfectly 5 factors, which is what we want. And then 5, I'll just do a bit more. 5 squared will behave the same as 1, 2, and 3. 6, it was in the beginning I thought it was okay because you can do 1, 2, 3, 6, there's 6, right? That's 5. Perfect. But I forgot it's a square, so you also have the um uh you also have 4 and 9, and that I missed. And if I did a sanity check, I read alarm bells should be ringing because 4 squared and 6 squared are completely different. 4, the factors of 4 is 2 and 2. That's so there's going to be repeats. But in 6, it's 2 and 3. There's less repeats. But how come they have the same amount of factors? they don't, and that should have rang alarm bells. Well, to simplify the process, 4 and 4, you find a factor that is a square, right? So you can skip a few and you get to 9. 9 equals to 3 squared. So 9 squared will behave the same way as 4 squared. Yeah, and just to prove it, it's 1, 9, like the root, the fact, the result, it's, wait, 9, wait, sorry. Oh, what? Right. Oh, so sorry. Uh, right, and then the root times the factor, which is 27, 81. Oh, and also 3. Yeah, that's 5 factors. Yeah, so it should have been 4, 9, which leads to 16 plus 81, which leads to 81 plus 16, because you want the sum, is 97? 90, yeah, E. It should have been E. Yeah, not D, E, right? Um, yeah, 22 was also from the grade 7 one, but I forgot. Like, I remember the gist of it, but I had to refine the details. But anyway, since again, I'll just quickly go over it this time. Since each each three consecutive letters has the same sum, right? That means uh, if you have PQR, that's 35. But then QRS is also 35. What happened between the change? You removed P and add S, and somehow the sum does not change. This means that P has to be equal to S. So I just swapped everything in terms of those terms, and and if possible, I switch the terms in terms of Q and U, because we know what's Q and U. So yeah, so it becomes P plus Q plus U, because R equals to U, plus P, because S equals to T, plus Q, because Q equals to T, plus U plus V, it's plus P plus, because P is equal to S, and we already said S equals to P. So it's like this. So we care about the sum. So we know uh, yeah, each list of, so if we just take this, P plus Q plus U has to be 35 because they're consecutive. Q plus U is 15, so P is 20. And then uh, what's this sum? This sum is equal to 3 times P, which is uh, 60, because P is 20, plus uh, 2 QU pairs. 2Q plus U, which is equal to 3 times 20, plus 2 times 15, which is equal to 60, plus 30, which is equal to uh, 90, which is D. Okay, 23. Uh, yeah. this is kind of annoying. So basically you want to travel, so you got this cube, right? Like if you fold it, you get a cube. Um, and you want to get from A and then arrive to every single of the squares. So, uh, yeah. So the way to do this is just to count efficiently. Mm. So let's take this diagram as like a starting point. So first you're on A, right? And let's see. Let's see if I can draw a nice cube. Okay, so you're up here. So, uh, you'll notice there are uh, two types of faces. One is the ones that are adjacent to A. They're all equivalent, right? But then the other one, the last one, is the one that is uh, let's see, adjacent, like away from A, like this bottom one. Uh, I don't remember. What's this called? Anyways. Okay, so let's just start counting. You want to go to every single square. So the first one, you're at A, right? You're at this top one. And then you have to go to one of the adjacent ones. I'll just say this is down, and then going this way is right, going that way is left. And then I'll call this uh yeah, if you actually count the yeah, if you put the cube net together, you'll discover that the bottom face is F. So I'll just call this F face, right? So first you have to go down, down. Hmm, this, this is down, that's left, that's right. Okay, so first you have to go down, and next you have a few choices. You can either go left, or you can go right, but they're actually equivalent choices. It's just you got two options. So I'll just remove, I'll just care about the left for now. And just keep in mind there's two ways for each left. Because each face you go, okay, first, when you go down, you have four options. Times four. Okay, we'll just build this tree. The other way is to go um, to the F face. Okay, next. So let's just say you went to this. Oh god, this is gonna be so hard. Uh, okay, so your this is the top, right? So you go and you go on this front face. And then, let's see. There, that should be a bit clearer. You go on this front face. And then you go on the bottom face. Uh, let's see. It's gonna be like this, like this, like this, like that, that. Yeah. And now you're on the bottom face. So you still have that face, and that face. So, um, let's see. You can either go left or right. They're equivalent, so remember there's a times 2. Um, what I mean is you can go from, if you go left, you will go this, this, like that. So I'll just color it with here. And then once you do that, you only have one choice. You have to go to uh, here and then here. Yeah. So once you do that, you have one choice. And then if you go to the F face first, you can't go to the opposite side because once you go to the opposite side and you go one direction, you still have another face missing. So this is not possible. Um, okay. Now wait, let me see if I'm keeping track. Yeah. Now, holy crap. Yeah, imagining these are kind of difficult. Okay. Now, if we're going to go uh to the left face, which is this. Okay, now we covered 3 faces. Uh, you can now go to the bottom face, the F face. Let me just use the new color. You're here, and then you go down here, and then, hey, yeah, and then the F face. You got 2 options. You can go to ooh, rainbow. You can go to here and then do the other face, or you can go to here and go to the other face. So here you're gonna have two options. And now, if you instead, it was way faster when I did the question because I had to be quickly. I had to be quick, but uh, yeah, I shouldn't delete that one. We're still on the bottom face. Oh no, no, actually, no. Never mind. I did. I don't need this. We're still on the left face. Yeah. Uh, if you're on the left face and you decide to go to the like back face, like this one over here. If you take another left, then you could end it like I want to do rainbow. This or that. So that's yeah. So you can do two options and then you only have one option left. So this is also another two option, which in total that gives you, let's start counting. So this part is 2 plus 2, 4, times 2, 8, 8, no, so this is 4. So 4 times 2 is 8, 8 plus 2 is 10, so this is 10, and then 10 times 4 is 40, which is E, which I was correct. Okay, that took way too long. uh, yeah, 24 is more mathy, so I think that this is actually quite clear. Anyways, so the number of 385 three-digit number for which one of the digits is the sum of the other two digits. How many numbers between 100 and 999 have this property? Um, yeah. So again, this is a counting question. There's so many counting questions. And you just have to think of like how to figure out the cases. So if you have a zero, um, first, if you have a zero, what kind of sums can you make? Well, it's number plus zero equals itself, right? So let's start. Uh, how? Okay, so one of the digits is zero. You know, the other two digits are the same digits. So how many possible digits are there? Well, it's 1 to 9. 1 to 9. So how many digits is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 digits. So you got 9. And now, because how many ways can you form this type of sum? Uh, it's so let's just say A is that digit. So it's either A 0 A or A 0. It can't be 0 A A because this would make it a two-digit number. And that's the way we're going to proceed with this. What's the case? What digits can it be? How many ways can this be achieved? The next one is the doubles, right? And I calculated the doubles a bit differently because I thought doubles might have some weird permutation, but it turns out it's actually the same. Anyways, uh, so doubles, you can do two. So uh, let's call the singular digit a. So it's going to be a to a, sorry, to a, to a, or a to a, right? So that's times 3. And then what can a be, or more specifically, what can 2a be? 2a can be 2, 4, 6, 8. That's 4, and that's it. Which means a can only be 1, 2, 3, 4. Yeah, so 4 times 3. Next is if the digits are different. So I kind of did it over here. So if it's different, you can have 6 ways per groups of digits listed over here. No, actually, I was right to do doubles separately because the repeats actually remove some of the variations. Because this is times 3, but this is times 6. Okay, so we'll have a times 6. And then how many pairings of digits can this be? Well, I just brute forced it and then saw the limit. So if one of the digits is 1, right? Oh, if the smallest digit is 1, so you can do 1 and then 2 and 3, or 3 and 4. Like the difference has to be 1. And then you can up to uh up to 1 and 8 and 9. So what's the second smallest digit? It's 2 to 8. These are all your possible ones. How many are there? Uh, so 2, 3, 4, 5, 6, 7, 8. That's 7 digits. So the rule is basically if it's inclusive, it's the largest minus the smallest plus 1. So it's 7. And then next is those separated by 2. So um, this will be 2, 3, 5 up to 2. Again, 9 is a max, and then 2 less is 7. Yeah. So it's 3 to 7. So 7 minus 3 is 4, plus 1 is 5. Uh, and then for 3, it will be 3, 4, 7, up to 3, uh, again 9, but then 3 less is 6. So it's 6 minus 4 is 2, plus 1 is 3. 3. And then you can kind of see a pattern is minus 2 every time, but for 4, I'm almost already there. This is just going to be 4, 5, and 9. Yeah, so this will be 1 plus 3 plus 5 plus 7, which is equal to 2 times 8, 16. So it's just this plus this plus this. And what? Holy crap. Okay, yeah. Yep. And you just calculate it. 18 plus 12 plus yeah, um 96. Because that's Uh, 32 times 3, and then 2, yeah. And this is equal to 30, because 18 plus 12 plus 9, 6 is 126, which is B. Yeah, see, that was simpler than the cube question. And lastly, this is the first question that I like couldn't confidently solve within the time. Yeah, because sorry, number one, it's what was it? Wait, huh? Yeah, okay. Yeah, number one, it was long, and number two, uh, there were multiplications and like calculations, and I tend to like make mistakes with those. So what? Yeah. Okay, there. Uh, so you got students ABC, and then um they're tasting blueberry stuff, and uh some of the samples have blueberry, and some don't, and also the students can decide if they think it has blueberry or not. So there's four options. Uh, it does contain blueberry, and they think it's blueberry. It does contain blueberry, they think it's not. They It doesn't contain blueberry, they think it does, and it doesn't contain blueberry, and it actually doesn't. So uh, here's their table, but uh, to list down all the information, I made this table, and I think this is the correct thing to do. And remember, the percentages, I just organized it so that the top row is adds to 100. So each row adds to 100, not the whole square. Even though it's confusing, I'm just organizing my information. So yeah. So let's just fill it in. If the percentage of corrects on samples containing blueberry, so they guessed it has blueberry, and it does has have blueberry. So that will be 90% of all samples that contain blueberry. But then the wrong ones is 10% of all the samples that has blueberry. See, I got contains C, NC not contain, and then the guess check mark with has blueberry and X without. So this is our table. Now back to the question. What are we even trying to solve? Well, you got some condition where student B reports 315 more samples as containing blueberries than student A. And then here's the real question. For some positive integer m, the total number of samples that the three students report as containing blueberry is equal to a multiple of 5 between 8,000 and 9,000. And the sum of these values, m is what? Okay, that was pretty confusing. So let's just see what we have. So I listed out the information we have first, because it's so long, you really need to list it out. So student B reports 315 more samples as containing blueberry than student A. How can you report a sample containing blueberry, right? It can either be it has blueberry and you think it has blueberry, or it doesn't have blueberry and you think it has blueberry. Okay, so this is student B, and it's, sorry, let me just erase this. Yeah, it's this portion, the left-hand side. It's student B. You see, it's when it contains blueberry, number of samples that contain blueberry is 98%, plus it doesn't contain blueberry, and he thought it contained blueberry, which means he was wrong. So it's in the not contained row, but he was wrong, so it's the right side, so it's 14. So that's why it's 0.98 times C plus 0.14 times not contained NC. And then that equals to 315 more than A, which is 0.9 times C and 0.12 times NC. Okay, so now uh, we want to try to find. Okay, so that's that piece of information. What are we trying to solve? We're trying to solve what's the sum of this, which is what's the sum of the total number of reports that say it has blueberry. So again, we're dealing with the same sum, this portion plus, ignore the 315, that portion, plus C's version, which is this plus this. Oh yeah, by the way, it's this, and that, that. Okay. What other information do we have? We also have this information where it says 4,200 samples. There are a total of 4,200 samples, so which means C plus NC, the amount of samples that contain blueberry plus the amount of samples that don't contain, is 4,200. Okay, so we have 1 and 3, and we're trying to find 2, right? Okay, so we're probably going to need to solve for C and NC. And first we want to solve for C and NC, and then once we get that, we can deal with the sum in this equation too. And then see what conditions will lead it so that uh, it will equal to a multiple of 5 between 8,000 and 9,000. Good. So that's our big plan. So first, solve for NC and C with equation 1 and 3. So uh, NC equals that. You just rearrange equation 3, and then you plug it into uh, equation 1, where it's simplified, because uh, this equals to 0.98 minus 0.98 minus 0.9, and this equals to 0.14 minus 0.12. Okay. Yeah. So and then so I just brought these two to the left side. To the left side. Yeah. So um 0.08C minus 0.02C, that's 0.06C. And then 0.02 times 4,200 is 84. Why is that? Because that's simply 4,200 times 2 divided by 100, which equals to 42 times 2, which equals to 84. Okay, so, and then 315 minus 84, uh, 84, this is 1, and then this is 231, because this is 11, and this is 2. 11 minus 8 is 3. So we get this. So what is 231 divided by 0.06? So that's equal to 231. Uh, 0.06 is 6 over 100, which is equal to 3 over 50. So this is divided by 3. And then we'll times 50 later. And then times 50. Okay, now notice this is 231, right? What's this? 201. I accidentally switched the 3 to a 0 and I got the wrong answer. And that's actually that's the calculation mistake. But then also the logic part, I didn't have time, so I just gave up. Like I didn't have time, so it's not really giving up. It's just the time ran out. So let's do it properly this time. Uh, so for 23, the closest you can get is 7. So 21, 2, 1, and then it was because 1 down, that's 73. No, 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 7, 7, 7, 7. Yes. Okay, and then 77 times 50 equals to 76 divided by 2 times 10, and then plus an extra 5, right? This was a times 5 strategy that I spoke before. And okay, so 76 divided by 2 is around, it's 8, so it's 38. Add a 0 plus 5 is 385. So that's the times 5 part, and then you still have the 0, so it's 3850, not 3350. So, okay. So what we're trying to calculate? Okay. It was 0.06 C equals 231. So C equals 31 divided by 0.6, which means C equals this, which means NC equals 4200 minus 3850, which equals 350. Okay, so uh, I'll just rewrite over here as big things. Yeah, C equals um 3850 and C equals 350. Okay, now comes the hard part. We're going to deal with equation 2 now. and we want to find the conditions where equation 2 can satisfy the multiple of 5 between 8,000 and 9,000 condition. Okay, so let's write it out. Uh, 0.14. Yeah, okay. This, I agree, it was a pretty bad notation. Um, yeah, let's just use fractions if needed. I might, yeah, 2m over 100. And let's first simplify what this is. So it's 0.98 plus 0.9 plus 2m over 100, which, let's see. I'll convert everything to fractions later. What's that? Yeah, because this mix is not helping. Um, plus wait, 98 plus 9, no, 188, 188 over 100. 26, 26, 126 minus 4m over 100. Oh god, no, that's not how you do it. C and N C. Okay, now we're going to have to plug in C and NC. So this is 2m plus 188 over 100. What's C? C. C is 3850, then plus 126 minus 4m over 100 plus NC, which is 350. Yeah, okay. So, oh yeah, by the way, I looked at the solution, I know the outline of the solution, but the arithmetic, I'm just going to go through it so that I know it's doable. Yeah. So, sorry, bear with me. Um, yeah, this is. I'll just separate steps so that I don't mess up. 77. Is that faster way? I know. Um, times 38.5. I'll just do remember the point 0.5. Okay. Yeah, it's gonna be 8, 4, 6, 4, 2. No. 6, 64, 0, 7, 8, 15, 0, 4, 2, 4. 4 plus 2 is 6, another 2, 3, 5, 4, 4, 1. I can do the addition later. And then also half of 188, which is a 49, right? Yeah, so it's 8. 3, 1, 2, 1, 1, 7. Yeah, oh, I think I recognize that number. Yeah, should be around right. Uh, yeah, 7, 2, 3, 8. Oh, so wait, are you allowed calculators? Maybe. Yeah, okay. 126. It's 300. Uh-huh. 18, 7 minus, that's just 14m, right? Wait, 378, right? Okay. No, it can't be. It can't be. It definitely can't be because there's a point 0.5. Just freaking do it like this. Oh, 378 plus the half of 126, which is uh 36, which is 1 4 1 4 4 4 1. Okay, and then uh now lastly combine all this shit and you get uh 63m plus 7 6 7 9. Let me check. 7 6 7 9 plus 63. Okay. Ooh, okay. Great. Okay, now what was the next step? We need to fulfill. So that's the sum, but we need this sum to fulfill this condition. Multiple of 5 between 8,000 and 9,000. How do we do that? Oh, okay. No, this is doable. This is the next part. Uh, and during the when I did it, I didn't like get to this logic part because like I had the right ideas iffy. Anyways, yeah. So, uh, this needs to be the 0. Oh, like when you divide by, it has to be divisible by 5, which means the ones digit, because I know this whole thing, like we only care about ones digits, because 10 is divisible by 5, blah blah blah. So ones digit has to be either 1 or 6, right? Because the next one is 11, which is outside bounds. If it's 1, you get 7, 6, or something, something 0, and that's divisible by 10, which is divisible by 5. If you get 6 is something, something 5, and that's divisible by 5. And there's only 9 digits, that's all you need. Which means, oh, by the way, when I say this digit, I'm saying like the ones digit of this has to be 1 or 6. If the ones digit of this has to be 1 or 6, so 60, when you do multiplication, right? It's m is this, only this matters for the ones digit. So 3 times something has to end with a 1, and that means that digit has to be m's one digit has to be uh 7, right? Because 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, that's okay. 3 times 8 is 24, 3 times 9 is 27, which, yeah, and 0 goes to 0. For 6, the digit has to be 2, because 2 times 3 is 6. 3, 4, 5, 6, 18, no. 7, 8, 9. Yeah, it has to be 7 or 2. Okay. Hmm. Okay, now the question is, uh, how about getting in range of uh, getting in range of the 8,000 to 9,000 condition? 8,000 to 9,000 condition. Hmm? So, okay, so 8,000 minus 7,679 equals to what? 1, uh, wait, give me a sec. 2, and then 421. So, so that means like, m times, uh, like 63m has to be larger than 421. Some estimation. If I do 7, then 63 times 7. I know it's this is 1, 2, and then this is 441. Okay, that's right. And if you do less than 7, it's under, right? So m has to be at least 7. What's the max condition? Uh, well, 9,000 minus 7,679 will equal to 1,421 because that's 1,000 more. Which means 63m has to be less than 1,421, which means that, or less than equal. Yeah. m has to be less than or equal to, do some estimation. How do I do this? 20? 30? 20-ish. Let's see. That would be 1, 2, 6, 0. How many am I off? I'm off by that many. 5 more? 4 more. 4 more, yeah. 2. 63 times 4. What's 63 times 4? Um, hmm, 20, 63 times 25. What? No, no, no. 63 times 5. No, no, no. Sorry. It's 63 times 5. Wait, oh God. Let me erase this. 63 times 5 is 5 131. Okay. And then that's under 63. Okay, so it's at least 20. Was it 5? Yeah, because that's 20 and that's 5. 25. So M is between 7. It's between 7 and 25, and either ends with a 7 or a 2 digit. So that's just 7, uh, 12, 17, 22. You can't do 27. And that's it. And then the total is 24. Oh my, no, 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 no. 19 plus 39, which is 8, 158. What? I don't think that's an answer though. I must have. Hmm. Yep, no, that's not the answer. Uh, let's see, where did I go wrong? Hmm. I know up to here it should have been correct. So, too much. Hmm. Give me a sec. Let me see if I can figure this out myself. Wait, what am I doing? No, that's not 421, it's 321. Yeah, right? Yeah, there's no, yeah, it's 321. It's 321, which means, uh, 63 times 5 is, uh, right, right? Yeah, no, okay. That's 5. Hmm. Then I must have messed up for this one too. 1, 1, 6. Yeah, so it's only 20, which means it's 58 minus 20, or 38. Nope, not that either. How? Hmm. No, wait, I even calculated wrong. Oh no, not mine. It's minus 22, not 20, so 36. So okay, yeah, okay. Okay, and the answer is B. Right? Yep, right. Okay, so that's all the answers. Yeah, I would be updating the doc soon, and yeah, hopefully this was useful. And my thoughts. Guess grade 8, I don't know. It's still applying the same principles as grade 7. It's just there were a bit more, like, there were a bit less freebies, which means my brain energy was sapped a bit more, which made me more prone to making dumb mistakes. Uh, and then the last question required a lot of calculation, and yeah, even if I didn't run out of time, I think I'll still make a lot of calculation mistakes. So yeah, make sure you get your algebra and calculation up like up to speed. Actually, I'm curious, is there any uh calculators allowed? Like, cause a lot of uh like math exams in university had no calculators, so I just assumed. Wait, oh, so there are calculators. Oh, I did everything by hand. I mean, yeah, so I guess that was penalty. I forgot. But I would have still made. Ah, I mean, if I had a calculator, I would like notice there were problems here, and I wouldn't need to spend so much time like trying to find 25, which would allow me to like check my answers. But yeah, excuses. Anyways, yeah, I guess. See ya.